So there are two potential pitfalls of using recursion, these are stack overflow errors and inefficiency due to redundant calculations. Here's a closer look at these issues and ways to overcome them. So first, you have stack overflow errors. Each recursion function call consumes stack memory, and if a recursion has too many levels, it can lead to a stack overflow. This is a this is common in languages with limited stack space, especially when the recursion is deep, like calculating Fibonacci sequences or traversing deeply nested data structures. So the solution to this is firstly recursion optimization. Some languages optimize tail recursive functions, which helps reduce stack usage. Tail recursion occurs when the recursive call is the last operation in the function. By reusing the current stack frame, this technique reduces memory consumption. Another solution is converting to iteration. Converting the recursive function into an iterative one with loops avoids the stack entirely, eliminating the risk of overflow. For example, many recursive tree traversal algorithms can be converted to use a stack data structure explicitly. Another error problem could be inefficiency due to redundant calculations. In some recursive algorithms, like calculating Fibonacci numbers, the same subproblems are often solved multiple times, leading to exponential time complexity. This can make recursion extremely inefficient for certain problems. So, one solution for this problem is memoization. By storing previously computed results in a cache, we can avoid redundant calculations. This technique transforms an inefficient recursive solution into a more efficient one, often reducing time complexity significantly. In the case of Fibonacci, using memoization reduces the time complexity from O to 2 times n or O to the power of n or O to n to on on. These so then the next solution would be dynamic programming. For complex recursive problems, dynamic programming is often a better choice. It builds up solutions from the bottom up iteratively, storing intermediate results to ensure each subproblem is only solved once. Dynamic programming is particularly useful in programs involving overlapping subproblems and optimal substructure properties. By being mindful of these pitfalls and applying techniques like tail recursion optimization, iteration, memoization, or dynamic programming, recursion can be used effectively without sacrificing performance or risking errors. Thank you.